So for the intrinsic gallium arsenic, the room temperature of the electrical conductivity is 10 to the power of minus 6 ohms per ohms meter. The electron hole and hole mobilities are respectively electrons and holes mobilities are respectively 0.85 and 0.041 meter square per volt per second. Compute an intrinsic carrier concentration at the room temperature. This is the data is given. So right, what is the conductivity of electron, or the conductivity of the electrical conductivity is given 10 to the power of minus 6 ohms per meter is there, and the mobility of electron is given, and mobility of hole is also given. Electron and hole is also given, right, as it is. Some value, both values. Now concentration of carrier concentration n is going to determine here. We know that the formula of the relation of electrical conductivity of a semiconductor, intrinsic semiconductor, is given by n of I into E of mu of E plus mu of H. This is the relation or the formula for conductivity in intrinsic semiconductor. So we want Ni, so Ni keep as it is. Remaining conductivity divided by E into mu of mobility of electron plus mobility of holes. So substitute the values, all values, 10 to the power of what is it, minus 6 divided by E. E is what, 1.6 into 10 to the power minus 19 charge. So mobility is given, what is that, 0.085 plus 0.04. this is there. So simplify this value, then we will get some values, 7 point something or 7 10 to the power of plus 12 meter per cubic. This is the intrinsic carrier concentration at the room temperature. Now second, the following datas are given. The datas are given. What are the datas given? Datas are given here. The carrier concentration is equal to 2.4 into 10 to the power of 19 per meter cubic, and the mobility of electron is given 0.039 meter square per volt and per second, and mobility of holes is given 0.019 same unit. So what you will determine here, so the calculate the resistivity, not conductivity, resistivity of an material. So by this also we know the conductivity, we know the conductivity of this relation. What is that conductivity? Conductivity of this is Ni, what is once again into mu of U plus mu of H into Charlie. This is the conductivity. Then formula for this, we will reverse it. What will be the what is the relation of conductivity and resistivity? 1 by rho. Therefore resistivity can be written as 1 by rho. Conductivity, 1 divided by conductivity is what, Ni E mu mobility of electron plus mobility of holes. This is it. Substitute all values, Ni you know, E you know, so then you will get the value that is near about 449 ohms per meter. You substitute and calculate, nothing is there, adding and subtracting. So this is the resistivity of this. Conductivity means you make the reverse of that. 1 by resistivity, nothing but conductivity, that also you can determine this. This is how many minutes is there? Wait, another one will do. Give. The pure germanium at 300 Kelvin, T is equal to 300 Kelvin, has a density of charges 2.5 into 10 to the power of 19 per meter cubic. A specimen pure germanium is dropped with the donor impurity atoms to rate of 1 impurity atoms is every, that is 10 to the power of 6 atoms of germanium. Assuming that all the impurities atoms are ionized, find the resistivity of dropped or doped germanium if the electron and hole hole mobilities are, okay, what is that, 0.36, okay, 0.36 and 0.18, so respectively, and the number of germanium atoms per unit volume is equal to, okay, 4.2 into 10 to the power of 26. These are the given data are there, okay. Summary once again for all, right? What is that? Okay, 2 is, what is that, carrier charges, density charges for the intrinsic state, that is Ni is given, temperature is given, and the germanium atom is equal to 10 to the power of minus 6, 10 to the power of minus 6 it will be, and 1 by 10 is 10 to the power of minus 6 is there, and the mobility of electron is given, and the mobility of holes also given. The number of silicon per atoms is equal to n is equal to 4.2 into 10 to the power of 28 atoms per meter cubic is there, because these are all about the given data. Once again rewrite all, nothing you are going to do, wait. Okay, now we will start the formula word. What is that? See, the number of impurity atoms, okay, in, okay, per meter cubic is can be written as the ratio of impurities atoms to germanium atom into the number of germanium atoms. The ratio of number of impurities is how much? 10 to the power of minus 6 is there. It is 1 by 10 into 10 to the power of minus 6 into number of atoms, how much? 4.2 into 10 to the power of 28. You multiply this, means 4.2, this 10 to the power of, okay, 20 minus 6 is this 28, not 28 minus 6 is 22. This is the value. But all the impurities atoms are ionized, therefore the number of free electrons due to impurities, okay, impurities is equal to 4.2 into 10 to the power of 22 only. From the law of mass of action, we know that number of electron and number of holes is equal to concentration charge square. So that will n of h, okay, number of holes is equal to n of I square divided by n of E. So n of I is 2.5 into 10 to the power of 19 square divided by n of E, okay, n of E is 4.2 into 10 to the power of 22. Make this, okay, simplification, then you will get 1.488 something into 10 to the power of 16 per meter cubic, okay. Now the electric conductivity, what is the formula? We know that formula, electric conductivity is given by the relation, okay, Ne, okay, Ne, okay, Ne, this Ne you write, or you can write direct Ne into e to the power of mu plus Np into e to the power of mh, okay. Now conductivity can be written as, what is this? Ne is equal to what? Ne is equal to N is equal to number of electron, how much? 4.2 into 10 to the power of 12, take is Ne common, into 1.6 charge into 10 to the power of minus 19, okay, into mobility of that 0.36 plus, okay, again here 1.48, okay, 1.48 into 10 to the power 16 into again charge 1.6 into 10 to the power of 19 into mobility of holes 0.18 is there. Simplify all these things, then you will get here, okay, 2419, okay, seconds per meter square, 7 per meter square. So this is the conductivity of that. But resistivity is equal to what? The resistivity is equal to 1 by sigma conductivity, reciprocal of conductivity. So substitute the values, okay, 1 divided by this value 24 something, then you will get the value of 41333 ohms meter, 10 to the power minus 14. Please check it, okay, equation, stop it.